That is a challenging one. I mean, there's never a recipe in anything as complex as science and a scientific career with all the obstacles and challenges to get into academic science.
Talk to our imaging scientists and to tell the young scientists and the other imaging scientists in South Africa who are the people who's really passionate about microscopy. Welcome.
Thank you very much, Lisa. It is a great pleasure to be on this series of podcasts, and I feel honored that you actually approached me about this. And it's an interesting time in my life and career because I'm considering taking retirement. I can't believe I've been around for such a long time. And it's actually a good time to think, what have I been doing the last few decades, and what came out of it and why it was such an enjoyable time. So yes, thank you very much.
We are very, very glad to have you. So yeah, you had a very long career. It would be nice to actually know, where did it start? Where do you come from? Tell us a bit about your journey, please.
Hey, yeah, it's kind of a long story. Really, I can start where I was born or where I come from. It's a small town in the Black Forest in Germany near the Swiss border. So we grew up with long and cold winters and lots of snow, and also and I got to think about it only this past few days when it got so cold, and it reminded me of my old home back in Germany. And the best thing about it was actually we didn't have to go to school, because when the snow was so high and the roads were covered in snow, the school bus wouldn't run, and so we could just stay at home in the warm. So it's funny how these memories pop up, and so that's where I came from. That's where I attended school in the Black Forest, and yeah. And then later on, the reason how I got to South Africa, or the circumstances, actually, I was chosen as an exchange student to come to South Africa just for 3 months at that time, back in 1981. Can't believe that's now more than 40 years ago. Quite crazy, and the accent still stays. Yeah, and I don't lose my accent. But however, that was the starting point. Yeah, I mean, during that exchange program, this country really captured me. Yeah, and I just thought I have to come back for more. Then obviously met my future wife to be at that exchange, and I mean, love does a lot of things. The country and the love made me stay here, and then I came back after I completed high school and did was meant to be a gap year on a farm near PE in the Eastern Cape, Kebecha nowadays, now PE then. And the gap year from 1 year became 3 years. And so only then did I actually make up my mind I wanted to study, go to university. I always had that idea we need to try lots of things in our lives and get lots of experience. And so after that time in the Eastern Cape, I got to study biology back in Germany in a place called Konstanz on the Lake of Constance near the Swiss border. Lovely place. I enjoyed it very much. And that is really, well, where I laid the foundations for my imaging. Maybe I actually laid them even earlier because my dad was a school teacher. And when I was a kid of maybe 10 years, he bought me a small microscope, one of these really cheap and nasty things where you can just see things crawling around when you take a little bit of a sample from pond slime, things like that, paramecium. I saw these living little creatures under the microscope, and it fascinated me no end. And I think that was actually the initial start to my involvement with imaging. But then going back to university, that is where I actually had my first contact with proper microscopes back in Germany during my under and postgrad studies. And yeah, I'm endlessly grateful to my then mentors and supervisors because they fostered that. And I thought that was so important that there's somebody who fosters that interest and generates the interest, stimulates what we can do with imaging. And so that's where it really started. Looking at what did I do then back at university, and my master's and PhD projects dealt with the development of the nervous system. And I became then aware that it is so important to understand not just the biochemistry and the physiology of things, but where do things happen and how do they happen in terms of structure. And so using microscopy then allowed me to really look at the structural aspects of development in, first of all, it sounds strange, but I first looked in my master's project at the development of the locust central nervous system, the stem cells, and the offspring of neuroblasts, and then the differentiation of nerve cells. And it was such a wonderful thing because you can look through that nervous system with a suitable microscope with DIC, differential interference contrast. You can see each and every cell in its detail, which to me was an absolute marvel that I could actually I could basically call each cell by its first name because, you know, they all, it's a very reproducible and a stereotyped system. And so that was really a fascinating experience. And in my PhD, I moved on to a study on regeneration of nervous system axons in the central nervous system. And my particular interest then was that certain vertebrates, fish, amphibians, reptiles to some extent, have this amazing capability to repair central nervous system injuries. Unlike we, as human beings, we just don't have that ability to repair damage to the central nervous system efficiently. And so what captured my attention then was really the fact that, for example, these amazing creatures we know as axolotls, so they're actually quite prominent nowadays in the labs, and they have this unbelievable capacity to restore axonal connections after an injury. And my PhD was a lot about looking at cells in that nervous system, how they reconnect after an injury, and to follow individual axons, trace them, and to follow their progress as they attempt to repair a damaged part of the nervous system. And for that, I used a lot of video microscopy. And I spent days and weeks and months literally in front of the video microscope, analyzing the behavior of individual axons growing in such a nervous system in live preparations. And then, so
was this all now in Germany still, right?
That was all still at the University of Constance, where I did my PhD project. It was in the lab of a Professor Claudia Stürmer. She was at that time a pioneer in this kind of research. And yeah, and so then after I completed that PhD, which I really enjoyed very much, and the insights that we got just from observing the behavior of these different nerve fibers and axons and growth cones, we learned a lot from that. Just by using good imaging approaches, suitable technology. It wasn't even very high tech, but it was a technology that allowed us to see details of nerve fibers as they grow. And later on, we started tracing them with suitable fluorescent tracers, the axons, and we used expression analysis of certain cell adhesion molecules that gave us an idea what kind of equipment the fibers use, the axons use to find their targets. So it grew from an observational project where you analyze behavior of single cells to look how are these cells actually equipped to do this kind of thing and to navigate, and also linked to that, what actually makes certain axons not succeed this. And then that led us to the story of myelin-associated growth inhibitory proteins, which we know, for example, in the mammalian nervous system, prevent regeneration to a large extent. Yeah? So then we got down to the molecular basis. And the marvelous thing was that we could link the microscopy and the structural analysis to the actual analysis. Where are the molecules expressed at what time? And that is what microscopy is much about for me. We understand where things happen and when do they happen. We can look at really small details of cells. Unlike biochemistry in those days, I mean, you had to mush up and do a Western blot, and you could not tell detail where is something happening and where when exactly. And so the structural detail escaped us till we used the actual imaging combined with suitable labeling techniques. So yes, and that was still back in Germany, and but South Africa never let me go in a way. So coming back, I mean, when I had completed my PhD in Germany, I saw an advert, and it was the early days of the internet, and UCT had put an advert out looking for a neurobiologist here at the medical school. And I thought, and I said to then my wife, look, this thing has my name on it. And then I applied, and yeah, like a few months later, I actually took up my position here at UCT, and that was in 1999, which is now 25 years ago. And here I've been ever since. So
I am very sure that South Africa has gained and Germany has lost a little bit. So yeah, thank you very much for coming back. It is absolutely wonderful to have you here. And I know that when I started with microscopy, you were one of the big names already. And everyone said you need to learn from Dirk Lang. So we are very happy that you've come back to South Africa. I would like to ask you a little bit. You have done 25 years of research then in South Africa. Tell us a little bit more about the research and maybe some highlights of this research 25 years in South Africa.
Yeah, basically, I must say my own project as a researcher stood back a little bit because I became very soon responsible for the microscopy facility here at UCT. And I often thought like, oh, I don't have time to do that much of my own research, but ultimately it's outweighed by the absolute privilege to witness what many of my colleagues are doing to contribute to lots of projects. And so my own research continues, it still continues in the way of understanding regeneration of nervous system and repair of the nervous system better. I've published quite extensively, usually within collaborations. And but what I almost find more exciting is actually to work with other people in other fields like immunology, cancer biology, developmental biology, botany. We have it all. And that actually absolutely fascinated me when I started building up the imaging facility here at UCT. That I've realized through the imaging, I get to work with so many fascinating people on really groundbreaking projects. I mean, I don't even know where to start with. I mean, I had people looking at mycobacteria, tuberculosis, how it invades brain cells, and how the actual bacilli lodge themselves in neurons, and that we managed to figure out with confocal microscopy. I had people from paleontology coming to use our two-photon laser to analyze the enamel on dinosaur teeth. I mean, unbelievable. I never thought this would be possible, yet we managed to do it. And it just shows how diverse an approach imaging can be and how valuable it is. The thing is, you have to think out of the box. It's not a one-size-fits-all, and it doesn't come in a kit. With biology these days, we often have the situation, people love to use their kits in the lab. Imaging does not. Yeah? You have to think what you want to do and what you want to see. and you need to think very carefully how you're going to analyze it. Yeah, and I mean, going back to your question, really, the highlights for me are manifold in biology. In other words, I can't even say it's that and this or the other in particular that I would say for me was the big achievement. It is the sum total of all these experiences, because it also allowed me to learn on the job. Yeah, and it also, that probably relates to where I come from, being a trained zoologist, really. At first, I wasn't an imaging scientist. I just grew into it because I realized I want to understand what is happening here in the spatio-temporal scenario. And that led me to embrace imaging, because it allows us to look at these things, yeah, beyond genetics and beyond biochemistry. And so that's how I got into this. Yeah, so I'm notoriously bad at making plans considering my career. I never actually went and said, I want to be a professor at UCT one day, just like applied, and then they took me, and then the opportunity came to really start the imaging facility. A nice little aside that I keep remembering so often is that when I started my job at UCT, one of the senior staff here asked me, because there was no fluorescence microscope back then here at UCT, not in our department, I mean, imagine that, eh?
Not today, no.
And so I wanted to apply for a fluorescence microscope, and together with my then colleague Liz van der Merwe, who is now also retired and emeritus. And so people asked me, senior staff, why would you want a microscope? That is so old-fashioned, what? And I thought, like, how far we have come since then, yeah. And so, yeah, the point is, I did not grow with the vision to become an imaging scientist. It grew on me because I realized I can use it to answer questions and to actually get involved in a variety and multitude of really fascinating research. And so it happened. So that led to us then building up the core facility here at UCT, and then becoming a core facility manager and head of the imaging facility. You just spend a lot of time with other people, and your own research takes a bit of a back burner, yeah, but I never found that to be a major disadvantage, because I enjoy being part of a bigger project and to collaborate. And so I'd say there is no clear, this is my big achievement, except that I was maybe the guy who brought confocal microscopy to UCT. That's what I say is maybe the most lasting achievement, because when we see where we are going now, and we have these fascinating and energetic young people, that all builds on that we created this awareness. Yeah, so I don't want to get carried away.
No, it's fascinating, and it's also wonderful. I think it's very motivating to young scientists to know that despite the fact that you might not have an exact plan, sometimes you find it when you just follow the opportunities. And I think that is, to me, a message that just came out here is keep on following the passion and the dream and go on. So thank you very much. This is a fascinating story, and I hope that the students really think, and I'm sure your name is going to be lost long after you've retired. I hope you enjoy the retirement as well. Our time is basically finished, but yeah,
talk too much.
It was fantastic. If you would say something to a young scientist as encouragement, apart from follow this dream that I've summarized, what else would you say to a young scientist now in South Africa, if you have something?
That is a challenging one. I mean, there's never a recipe in anything as complex as science and a scientific career, with all the obstacles and challenges to get into academic science, not many positions, and the economy is not doing really great. But I'd say from my own experience, maybe that's easier said than done. Be true to yourself and do what interests you and stay motivated. Because if you're motivated, you will radiate and people will find it attractive and you can perform at your best. If you do something that not really interests you and you're just doing it to earn a buck, it carries you for so and so long time. But if you are really enthusiastic about what you do, then you're willing to put in the long hours and the hard work, and you will be rewarded. And I think that applies anywhere in the world. Yeah. But there is unfortunately, no one-size-fits-all recipe or generic recipe how to succeed in academia. From our own experience, I would also say just sometimes be tough against others that want to burden you with too much admin and things like that. Life is not about sitting in meetings. Life is about doing things in science and never lose the sense of marvel of looking at things. And for me also it was really important, I should have mentioned that sense of aesthetics, the sense of beauty that you get from looking at biological specimens under a microscope, to me it's still one of the driving forces. Yeah. And I believe, especially if we stay in touch with overseas people in imaging, there's a huge willingness from overseas funders to actually set up imaging facilities, sponsor training here in South Africa, because there's a need for these techniques. Not a lot of money going around here in the country, but the Northern Hemisphere, Europe and Africa and America, there's a lot of willing organizations to support us here. And I think it's really a good idea to get in touch with them. And then they have you on the radar. And I think then you're already much better equipped to deal with the challenges here in South Africa. That's my really 2 cents of wisdom, I'm afraid.
It's wonderful. It's really actually too short. I didn't realize that we are going to talk so much. And there's actually, I guess, from a career, how many years did you say? I can't remember now. 25 years in research.
25 years at UCT.
To UCT. I am sure that you have a lot to share, and but we are running out of time. And I want to thank you for your time and for your passion. It shines from you. I can tell. Yeah, may you retire with a lot of joy, and don't forget about science and all of that.
Yeah,
I think you're an inspiration to all the scientists in South Africa.
If people want to get in touch, I mean, please tell them they're more than welcome, and I'm not going to fall off the planet. I just plan to spend a lot more time out in the nature and hiking the mountains and things like that. So yeah, that's the idea.
Very exciting. And I guess a lot of people would be very jealous of that time that you can now spend. It's well deserved. That I can say.
Thank you very much again. I loved it. And yeah, so as I said, anybody wants to know more, I'm more than willing and available to chat and give advice if anybody needs any. So that's, and I'm just grateful for all the young people who are picking up the imaging. I know you are also involved with the South African bioimaging and which is in the worldwide context of the actual global bioimaging community. And I think these are things I could never have dreamt of back in my days. Yeah. So thanks to all of those who are picking that up, because I try to not be sitting in too many boardrooms and not too many meetings, as I said. So I'm very grateful for everybody who is taking things to new heights. And I know there are lots. And yeah, I think
it's exciting times. So yes, thank you very much. And I'm going to greet you with that. And we appreciate your time a lot. Thank you very much.
Thank you very much for the interview time. And I really enjoyed chatting to you.
Thank you. Thank you, Dirk. Bye-bye.
Bye.